When you are ready with the necessary knowledge required to learn general relativity, when your preparations are all done, the first question that rings in your mind is, which textbook should you start with? Which one is the best for you? Now, there are so many good textbooks for GR that are available in the market, but which one would be the best for you? In this video, you're going to learn the first textbook that you should start reading. You're also going to learn why that book is best for you and what are the necessary steps required to start with this new learning. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to this fresh new video on selecting the first textbook to learn General Theory of Relativity. Now, as you understand, the basic problem with human beings are to make the right choice, because options are so many and we first get confused and then perplexed by making the right kind of a choice. Now, if you go to Google and if you go to Amazon and you start typing General Relativity or best books at General Theory of Relativity, you will come across numerous books and some of them will resemble something like this, which you can see on the screen. So there are so many books available on general relativity. Each one of these books claim that they are the best book. They are going to teach you this is the first, best and the most easiest approach. Now, as a student or as a learner, the question comes as this: how to make the right choice? And this is what we are going to first address in this part of the video, that what is the right choice. Now remember, the right choice for your friend or somebody else might not be the right choice for you. So we undertake a general quest that how to learn General Theory of Relativity, and here we simply see there are two options. The first one is called that you undergo a graduate or undergrad course and you learn the underlying mathematical concepts which forms the foundation of general relativity. You learn the concept, you learn the physics, everything, and then you start learning general relativity. The second thing is that no, you don't understand or you don't go ahead with that kind of an approach, but you simultaneously learn the physical concept as they arise, allowing the theory to unfold naturally alongside with your mathematical journey. That means you just pick up a book from the shelf and you start learning. Wherever you are stuck, you go back and again you learn, you come back, again you go back and you come back. Now, either of these options have got its pros and cons. Now, if I go with the first option, definitely it is going to take a long time, because General Theory of Relativity, the mathematics, the physics, the concepts, etc. is going to take a long time and the students might feel, oh, this is not my cup of tea. I should not go ahead because mastering those foundation will at least take about a year or more than that. The second option also has got a problem, because if you go back and come back and if you go and come back constantly to and fro, then there is a confusion. The confusion is that where will I go? Is this concept sufficient enough? Shall I go and learn further concepts, things like that. So the question arises that is there a middle way? Is there a middle path which actually helps you to understand and suffice both the need? Neither it is time consuming, nor it is too long, neither it is too difficult, nor it is too easy to go. Now that is certainly a kind of a yes. And what I would suggest is that you need to learn some basic concepts and then approach general relativity. And then you can take up the new concept, because whatever you do, there will be new concepts in the process of learning. Then you can take it forward. Now, over my specialization and years of doing and learning, researching, writing, guiding people in General Theory of Relativity, I have done at least round about 40 to 45 videos which are on General Theory of Relativity. But remember, all these videos were on the how to learn General Theory of Relativity, how to learn the tensors, the Einstein field equation, differential geometry, Christoffel symbols, beginner's guide, all those things. And with your love and your commitment and the way you have liked Physics for Students, all those videos have become very popular. And now what I assume that you know what are the prerequisites of learning the General Theory of Relativity. And if you don't know, here I would like to answer quickly that what are the essential prerequisites for learning General Theory of Relativity, and I would like to divide it into two parts. The first one is that what is the physics that you need to know? a very quick overview. The first is that obviously because general theory of relativity is a classical theory, I mean in some sense, then you need to learn the classical gravity, that is the Newtonian gravity. This needs to be learned. Then you need to learn special relativity. You cannot just skip over special relativity and start learning general relativity. The equivalence principle and its concepts are very pertinent. You also need to learn energy, momentum, and stress tensor. All these are related to physics. The gravitational waves, how they are detected, what is gravitational, what are gravitational waves, these things you need to learn. Also, there will be a lot of change of coordinates. So frames of reference and coordinate system, how do they change, how do they flip, how do they rotate, all these things are very, very important. Electromagnetism and cosmology, I won't say cosmology, yes, a part of that, not too much, but yes, electromagnetism will be required because you need to know the relativistic Maxwell's equations, so that is required. So very good understanding of classical gravity along with special relativity equivalence principle, and most importantly you need to visualize how frames change, rotate, stretch, and they scale up. So that is something which is required for the physics part. Now I'm not going to elaborate on that because these are already done in my previous videos, just to give you a glimpse. Now if I talk of the mathematics part that is required for general relativity, I would say that first would be differential geometry and curvature. This is the basic thing without which general relativity is not possible to learn. The big boy of math would be the tensor calculus. Obviously you need to know linear algebra and variational calculus. Calculus, multivariable and partial differential equations are very, very important, along with that Riemannian geometry. And I won't say that you need to learn topology and analysis, but if you do, fine, otherwise it is optional. Now all this taken together, what ultimately it leads to, that you might ask that what is the use? I understand these will be required. What would be the outcome of those learning? It gives you three clear outcome. The first is that with this it describes the space-time. So differential geometry, tensor calculus, these are all mathematical tools which are required to understand curvature, how things bend, etc. So this would be important. The second thing would be solving equations, because Einstein field equations and the dynamic, the partial differentials, all these are basically allowing you to find solutions, and you can describe how the physical phenomena actually happen. And finally, there is a very good physical interpretation, because whatever the mathematics or the abstract things that you are doing are basically meant to describe physical quantities in a consistent way and coordinate independent way. I've spoken that at length in many of my videos. So these are the clear three outcomes while you do into making the right choice. Now when I talked about the mathematics, I would like to draw your attention that very recently I've completed almost 6 videos, but 4 of them are very important, and it is in my playlist, How to Learn General Theory of Relativity. Go to Physics for Students, go to the playlist, and you will find all those 4 important videos. The 5th and 6th I have ignored because that is a non-Euclidean geometry, and the last one was a summary. So you can very well find all those videos. These videos are quite elaborated. As you can see, the durations are all more than 30-35 minutes. And this would actually lead to a much better elaborate understanding of why these things are required, etc. So making the right choice is important, and this is how you need to make the right choice. Now, after having made the right choice, the question comes that there are 2 types of books when you deal or start with general relativity. The first one is called the preparatory books of general relativity. That means the books that makes you prepared. Although I have made enormous videos, around 50 plus videos on how to learn general relativity, still I would like to tell you that there are very few very important books which are required. Now when I talk about textbooks for learning general relativity, they are divided into 2 parts. The first one is that some textbooks assumes that you know all those things, and they dive directly and start with the mathematics or physics of general relativity. The second one is that they will go into the concepts of general relativity, but before that they will give you a brief overview, brush up, give you a kind of a prerequisites, and then go on. I would say if I talk of the preparatory books. So preparatory books can be 2. Again, subdivided. General relativity has 2 types of books, preparatory and textbooks. Preparatory books have got 2 types. One is that straight going into the mathematics or the physics. Another is giving you a brush up. I would like to show you just few important books which will first give you a brief overview, make you aware, make you ready that yes, you are ready to take a deep plunge into the ocean of general relativity, and then you can go ahead. And among them, the first book which comes across is this one, The Physical and Mathematical Foundations of General Relativity. As you can understand, the title itself tells that it is basically for building up the physics and the mathematical foundations. So I can tell that this is a very rigorous mathematical approach, and it helps you to analyze the foundations of general relativity and its implications, and it thoroughly examines the transition from classical, we will see that, classical mechanics to special and then to general, so that it gives you a much more broader, stronger and a solid foundation of general relativity. Let us look into what are the topics that are being covered. So as you can see, it first starts with tensor algebra, exterior algebra, because this is the first basic thing, I mean to say elements of differential geometry. As I told you, it would give you first the basic understanding. So all those which are related to tensor algebra are being covered. The second thing which covers up the book is that manifolds. Again, it is being covered in differential geometry, parallel transport, geodesics. These are all very, very important when we will go into the textbook of general relativity. Transformation groups, exterior differentiation, geodesics, aviation. Here you can see Levi-Civita connection, Riemann's theorem, and Ricci decomposition. These are all very essential elements of general relativity. Further, then it will take you, once you get to understand all those 127 plus pages on the basics, then it will move into Newtonian dynamics, gravitation, cosmology. It covers at length a lot into Newtonian gravitation, because I told you the physics part will require Newtonian gravitation. Then it will cover up special theory of relativity, consequences, Maxwell's equations in vacuum, and relativistic dynamics, which is very important. Further, you can see that special relativity in Minkowski space, which is covering the four-dimensional, the four-vector, etc. Then it will take into continuous systems in special relation and magnetism in moving media. So you understand that these are all preparations. These are one of the preparatory books. Then it will come into introduction of general relativity, linearized Einstein's equation in case the things are moving slowly, Cauchy's problem for Einstein's equation, Schwarzschild universe, and then it goes into further into cosmology. So this is a very important, a very pertinent book in terms of understanding and making preparations of general theory of relativity. Here you can see Schwarzschild solutions, black holes, then elements of cosmology, Friedmann solutions, etc. are covered, and then there's the list of figures which are being used as usual. So if I now take a kind of a strict evaluation in terms of this book, then what I would like to tell you is that this book offers a very deep dive into the mathematical intricacies of relativity, making it suitable for mathematicians, students, and researchers. The mathematical rigor, yes, it is very much very much covered. The mathematical rigor. Critical analysis, I would say that the authors, both of them, provide a critical examination of the foundations of relativity, challenging assumptions, and then it explores the alternative interpretations. Yes, this is important. This book effectively guides the reader, or you will get a complete understanding of the transition from classical mechanics to special relativity and then to general relativity, giving you a much more profound understanding. The book focuses on the fundamental principles and concept, and you can get a solid foundation on further study. And yes, despite the complex, I would say, mathematics, the book is presented in a very clear and concise manner, making it accessible to those with mathematical concept. And if I take off the potential weaknesses also, because I have to be very unbiased, yes, it is very advanced due to the rigorous mathematical treatment. The book might be challenging for beginners. There is less emphasis on applications because the books provide a very deep understanding on the theoretical foundations. It might not delve into the practical part also, and it has got a very limited historical context. So not much of historical developments, etc. are being discussed. So this is about this book. What I can tell you overall, I can say you it offers a rigorous, critical, and a very mathematical understanding, but it will make your mathematics very, very strong, and its advanced level, it might come as a challenge for the beginners. But if you want to make a very strong mathematical foundation, this is the book, and the title itself suggests it. The next would be a relatively easier book, which is Norman Gray's A Student's Guide to General Relativity. It is very concise. It's very less, I think around 175 pages, but it is very good. I will show you why it is, because it will take you through the core ideas and the fundamental concepts, both in differential geometry, general relativity, etc., and it comes as a very good part. A few glimpses on the book. It contains very nice three-dimensional diagram, as you can see on this, and the equations are written very clearly and concisely, so you just don't need to be worry about the quality of the book. Everything is very nicely prepared. The content of the book is very simple. It's very less. So how many? 150 pages. So it will give you the basic introduction, vectors, which is required, manifolds, vectors and differentiation. Then it will go into energy, momentum, tensor, etc. And then it is done. Then the appendix actually covers tensor, coordinates, etc. So this is a very short, clear, and a concise understanding of general relativity, not much in details. Let me give you what I feel about this book. This book is written in clear, I would say concise manner, making it suitable for students or any beginner. Yes, the Professor Norman Gray actually emphasizes the physical interpretation of concept, and which will help you to develop a better understanding of the theory. Yes, it contains a lot of exercises and problems in reinforcing a better comprehension of the subject. And yes, you will get a kind of a brief overview of the historical development of relativity and things like that. So it provides a strong foundation, although the number of pages are very less, so you won't expect a lot of things which will come through, but yes, in some way it is good. Okay, if I come to the next book, then this is a very, very important book, and I would like to draw your attention on this book. But before I go on the book, as I always tell, that some of the introductory notes of a book is very important to understand the basic idea or the objective of this book. Now just pay attention of this book, what I have underlined in red. So the basic idea is to propose an original itinerary moving from Euclidean to non-Euclidean geometry, created from axioms to models, etc. So number one is to understand non-Euclidean geometry. Number two, to create language by which we can describe the general relativity and its consequences. So things are very clear and simple. The authors want to teach you that how you move from Euclidean to non-Euclidean, and this creates a language through which general relativity can be understood. So the physical world actually forms both of Euclidean and non-Euclidean, but we need to continue to the itinerary with supplementary Newtonian, Lagrangian. Last line is terribly important. The content of the book is written to be self-contained. That means you don't need to look for other references, which sometimes comes as a very disturbing element. There's very disturbing factor. So all the proofs are done with all the details presented to the reader. The problems are solved or they have hints. That means it's a mathematical journey, again a preparatory books which is give you the mathematical exposition. You don't need to go anywhere, it is self-contained and everything is written over here. Also, this is very important, that if someone knows mathematics, that is both basic geometry, that means this is the assumption. What is the prerequisite? Geometry and differential geometry, this person can neglect the first 6 chapters. So if you know differential geometry, you can skip the first 6 chapters. She or he can start from gravity, Newtonian mechanics. People who study physics should start from the very beginning in order to understand the development of geometry. They improve a mathematical language in more than 2000 so and so. So if you are a beginner, or those who are learning physics, you can start from part 1. But if you know differential geometry, you can start from chapter number 6. Also, it tells without the effort to understand the nature of non-Euclidean geometry, the differential geometry could not occur. That means good knowledge of non-Euclidean geometry, and that is why in my series of videos, all those 6 videos, I have made an exclusive video on non-Euclidean geometry. A lot of examples and solved exercises will help you, and so and so. So this gives you a clear-cut understanding of the objective of the book, and this is actually the content. It will start from Euclidean to non-Euclidean as promised by the two authors, and then the basic facts. It will move into geometric inversion, surfaces in 3D spaces, basic differential geometry. Then it will move into gravity, Newtonian mechanics, special relativity. So it will go actually as promised. Then it will go into the general relativity and relativistic cosmology, dealing with covariant derivative, etc. You can take a pause and you can just go through what the book actually comprises of. Remember, it also comprises of Gödel's universe, Rindler's metric and pseudo singularities, as well as the anti-de Sitter space-time and the FLRW metric. So it is a fat book, 393 pages. It covers and gives you a very good and a clear understanding of what is called the mathematical base. So it would create a great foundation of mathematics. So if you are trying to understand that which one you should start for, you can always start with Norman Gray's book. Then I would say go for physical and mathematical foundations, because this covers the transition, which will be better for you, and then finally go into the mathematical journey, because it is a little bit more mathematical in nature, etc. So I think that would be great. That would be the good sequence of study. So these three books actually comprise and completes the preparatory books part. And now we come to the textbooks of general relativity. Although I won't be talking too much about the text part, I mean to say, I won't show you too much of options. That would create a confusion. But the first book which I would like to show you is this one. This is Rafael Ferraro's Einstein Spacetime. Now this is actually, I think it is a Spanish or a it is a translated version of the book, and yeah, so this was by it is in Spanish, from the Institute of Astronomy and Physics. This is a general overview which I have taken from Amazon. So this is an extraordinarily thorough and compact primer on special and general relativity. So again, you see, this is again brushing up the concept of special and then going to general. And it says that the author succeeds in his undertaking to present the special theory and then introduces general relativity. The pedagogical approach is the strength of this book. And I will show you what do I mean by pedagogical approach in a few seconds from now on. So here you again see there are few things that are important. The author says that to understand the theory of relativity, it is necessary to give up our notions, intuitive notions of space and time. That is true. These classical notions of space and time are also the foundations of Newtonian mechanics, which dominated physics for over 2 centuries. That's also true, until they actually clashed with Maxwell's electromagnetism. So it says that you need to unwind yourself and start learning general relativity, which is a very good message, I think, personally. Therefore, we tend to resist abandoning the classical notions of space and time and to replace them with other notions. The historical approach of this text attempts to guide the reader along the same road followed by physics between the 17th and 20th centuries. After this journey, the reader will become more receptive to the consequences of the change in paradigm. So it's good news. I mean to say, it's very, 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 very clear that you need to come out, unwind yourself and learn. So here is basically the context. You can see it starts with a historical context, space-time, before Einstein, principle of inertia, etc. Then In Search of Ether, the luminiferous ether, the Hawks and Aries, Michelson-Morley experiment, etc. Then it will move into space-time relativity. Remember, these are the textbooks. So these are the books which will teach you, which will learn general relativity when you're done with the preparatory section. The geometric structure of space-time, and then the transformation of the electromagnetic field. Further as we go, we see that energy and momentum is being covered, covariant formulation, inertia and gravity, results on general relativity, which are actually the Schwarzschild solution, and then it follows with cosmological models, and then followed by the appendix. So what I can say about this book is that I will show you other books, but as far as my feedback is concerned, it is the clearest, easiest and the best mathematical explanations given, and it will give you a holistic understanding by brushing, clearing up the previous concept, give you an historical overview, then going into the subjects as well as the mathematics part. So if I take a kind of an understanding of this book, then I would say Ferraro's writing style is straightforward and easy to understand without a strong background in physics. He avoids unnecessary mathematical formalism, focusing on the core subject. Number 2 would be the historical context. Yes, the book provides a good historical context in the development of relativity, which will help you to understand the intellectual climate that led to Einstein's groundbreaking theories. Practical examples. Ferraro uses numerous examples in this book and thought experiments to illustrate the concepts of relativity. And most importantly, yes, it covers both special and general relativity, providing a well-rounded understanding of yours and of the Einstein's revolutionary issues. Now, if I go and take what are the potential weaknesses, I won't say these are, it should not be sound as weaknesses, but yes, I can say that there are some mathematical complexities. While the book strives to avoid excessive mathematical formalism, there are sections which are a little bit difficult to understand. There is a limited depth because those who are seeking for a very rigorous understanding, this is not the book for you. Overall, I can say it offers a very clear and accessible introduction to the subject and makes things pretty interesting and great for the learning part. The next textbook would be a classic. It is absolutely a classic book. It is the first course in general relativity by the famous professor Bernard E. Schutz. Now, I would like to tell you one thing, that in some of the, when I talk to people, etc., I see that some students feel that Schutz's book is not the first book that you should take up in general relativity. I would like to disagree with that, because I found the book of Schutz is extremely well organized. Maybe that you have not read this part of his introduction, that is why you are finding the book difficult. So as you see here, the book, the subject of the book remains to classical general relativity, apart from discussing the Hawking radiation. So there is still no clear direction of 2 points, because it is not covering what you need to learn, is called quantizing gravity. Another important part is this one, which I have underlined. So this book assumes, and you see Professor Schutz write, the students is assumed already to have studied special relativity, including the Lorentz star formation, relativistic mechanics, Euclidean vector calculus, ordinary and simple partial differential equation, thermodynamics and hydrostatics, Newtonian gravity, and enough elementary quantum mechanics to know what a photon is. So now, if you don't know this, obviously this book will become difficult. It's a difficult read for you. So that is why I always tell that before going into the book, start and read the first few pages, because it is important to understand what the author assumes. And it assumes you know special relativity, this, which I think is fairly good. It's good enough. Now, if I talk of the text part, or I would say the content, it will show you the special relativity, then vector analysis, then tensor analysis. All are, but these, you see that vector analysis in special relativity, tensor analysis in special relativity. Why Professor Schutz does this? Because it will be easier when you take those into general relativity. So special relativity vector analysis is much simpler to understand than general relativity. Similarly with tensor calculus. Then it goes into perfect fluids and special relativity, a preface to the curvature, curved manifolds, and so on. You can see, you can pause and just go through that these part. I won't repeat it again. So Einstein field equations, Schwarzschild black holes, and so on. So again, going by the review of this book, if I talk, okay, these are the some of the screenshots which you can understand. The book is clearly written. The gray boxes underline the most important parts. So first of all, I would say Schutz's writing style is very straightforward and easy to follow, making the subject accessible to students with a basic understanding. The book emphasizes definitely on physical intuition over mathematical formalism, which makes things easier. And Schutz uses a geometric approach, which is much easier than the mathematical approach to general relativity, providing a visual understanding of the concepts. And obviously it is very well structured, progressing from the fundamental concepts to the more advanced in a very logical manner. So I would say this is a highly recommended book for students and researchers to the theory of general relativity. It actually gives a lot of stress on understanding the geometric concepts and take into valuable resources of developing a very good solid foundation. Okay, this would be another great book. This is Spacetime and Geometry. It's my personal favorite, and it's by Sean M. Carroll. And as you know, Professor Carroll is a theoretical physicist, I would say a science popularizer, and who has got a good amount of knowledge in quantum mechanics, cosmology, and so on. Again, a important note regarding this book would be, as you can see, professor tells that surprisingly there are few formal prerequisites for learning general relativity. Most of the material is developed as we go along. That means what I told you right at the beginning, that you don't need to learn, just learn the basics. Professor Carroll is going to develop and make you understand while going through the journey. Certainly no prior exposure to Riemannian geometry assumed. This is a good news because Riemannian geometry is highly complex. So Professor Carroll tells that you don't need to know Riemannian geometry, nor would be necessary, nor would it be necessarily be helpful. Chapter 1 purpose is to give a more view and so on. And you can see the first chapter is a review of special relativity, again a brush up. Tensor algebra, discussing classical field theory. The next chapter introduces manifolds, chapter 4 along with some, and so on. So this is good, but remember the part that I will be showing you now, because I have a little bit older version edition of the Spacetime geometry, but there are very new and current editions which you can purchase from Amazon. So special relativity and spacetime, manifolds, gravitation, Schwarzschild solutions, quantum field theory, at last more generalized black holes, perturbation and cosmology. Although these parts seems to be very less in number, but I personally have gone through this book. It is very detailed, great, and a very good understanding of general relativity. So I mean to say, this is a very good book. There's no doubt on that. It gives you a complete understanding of that, of general relativity. So first is, I would say that Carroll provides a very lucid explanation of the Riemann curvature tensor, which is a very fundamental object in general relativity, and uses concrete examples such as the geometry of a sphere to illustrate these concepts. The mathematical introduction, I would say, are good because it introduces the concept of the metric tensor, which is the fundamental tool to measure. Then he goes into the physical meaning of the metric, explain how it determines the trajectories and particles and behavior and so on. Next, I would say, as I have already told you, the physical intuition is being covered a lot using geometry, and this is a comprehensive coverage. Definitely it has got quite a big coverage starting from the special relativity and going into quantum field theory. There are a lot of problems. Yes, there are a lot of problem sets which are in there, and it actually derives Einstein's field equation, and it relates the curvature of space-time and so on. And yes, it covers modern topics because quantum gravity, the search for the theory that unifies general relativity with quantum mechanics, is being covered, and Carroll provides a clear overview of the challenges and potential approaches to the fundamental problem. So what I can say is that a highly recommended textbook, a very good and an easy book to learn, understand, and make your journey pretty easy in terms of understanding general relativity. So now if I take the three books, you might wonder that which one shall I start first, and what is the justification? I would say go for Rafael Ferraro's book because it is very clear, good, easy, and the mathematics is fairly simple. Then you go to Sean M. Carroll's book because it is a very systematic development, a little bit, I would say, advanced mathematics than Ferraro's book. And then you go to the classic, that is Schutz's book of first course general relativity, because it is, the mathematical part is very, very, very rigorous. So having said that, I would say, I like to tell you that what is a quick summary, but the summary won't be in text. I would say that first I would pick up a book, and then just pick up any book that suits with your current level understanding. Don't go forward, not this, not that. You will waste a lot of time on that. This is important. Do not keep on searching for your ideal book. There's nothing called an ideal book. If you keep on searching, this is difficult, that is not, this is not my cup of tea, you will keep on searching. It is never going to happen. So just pick up a book, understand that it suits with your knowledge. Don't search for what is called an ideal book. Get your basic concepts clear through those books which I have told, or maybe through the videos that I have made, and select a book that first talks about the preliminaries and then starts with the main course. That would be my suggestion. Instead of going for a book which is directly jumping into the physics or mathematics of GR, it is always better that you get a refresher course or just freshen up your memories with a basic learning which is covered. So talk about the preliminaries and then go ahead with that. So that's it for today's video. Thank you very much for watching this, and if you have liked the video, please do subscribe to my channel and hit on the bell icon to get all the notification from Physics for Students. I always reply to your emails. You can write to my email ID on this, and this is my other channel which you can subscribe, General Relativity Explained, and you can follow me on my Facebook, LinkedIn, Instagram and Twitter account. That is all for today's video. I hope this approach will help you, and do let me know that what are the books that you're reading currently, how you have found those books in the comment box, and just wait for another few more exciting videos on general relativity and something very important and something very complex coming up on a very easy manner. Physics for Students will be back with those interesting videos, and stay tuned on this channel. Goodbye, and may the good Lord be with you.